So hello, everyone. I'm Robertson Taylor. I'm a solutions architect at Amazon Web Services. And my background is mainly working with serverless services. And one of those services that I'm excited to talk to you about today is AWS AppSync, that is essentially a managed GraphQL service. And throughout the talk today, we're going to have a brief introduction to AWS Amplify, which is a framework that can help you really speed your development process. Talk about the key uses and features, how it ties into AppSync, and then an introduction to AWS AppSync itself. And finally, we will explore some reference architectures of how you can actually use this for some practical use cases. And we'll close off with a demo. It's a lot to pack into 30 minutes, 35 minutes. So I apologize if I go a bit quickly. Please feel free to ask questions in the chat if I'm not being clear. So just jumping straight in, one of the coolest things about Amplify is that it's one of the fastest ways to actually develop mobile and browser-based web apps that can scale out. And basically, it's a set of abstractions that are built on top of common components that you might use in AWS. And it helps you really get your products to market faster, helps you develop them quickly, even if you don't have an AWS background and might not understand how to wire all of those services up out of the box. And it helps you really get to actually innovate and deliver results for your customers, which is at the end of the day what you're trying to do with any application that you're building, hopefully. And finally, it helps you deliver these results at scale. So it's not like it's a gimmicky component that's not going to scale up to actually meet your production use cases. It can help you build scalable production-ready applications. And it does this through a few different pieces. One of the first that we'll talk about is the underlying libraries for things like authentication or ID integration that helps it really integrate into your standard development workflows. Beyond that, you also have the ability to actually focus on innovating by using standard common components that you might have between different applications. So you can think of these as things like GraphQL. Like if you want to build out a GraphQL API and you don't want to go through the process of spinning up your own servers in the backend, writing your own mutations and figuring out the schema, figuring out how to convert that schema into resolvers, figuring out how to do batch processing. Amplify can really help you meet a lot of these goals by just a few simple CLI commands, as we see at the end of the demo. And you can do this with new data. You can build a new application on Amplify, or you can integrate with existing data sources on AWS. And all of this is pretty simple to test with your own frameworks that you're used to. If you're just building a React app, it's the same. You test it the same way you would build. You test it the same way you would test any other React app. And one of the key things that you'll hear in pretty much every AWS talk is all of these components can scale out and can scale up. They're frequently global components. One piece that you can get with Amplify is a content delivery network called CloudFront that helps you deliver content to your users around the globe, helps you manage caching around the globe, and helps you minimize latency for your users to improve customer experience. And the reliability and security are both components that also kind of come out of the box. So for reliability, you can use AWS managed services to remove some of that undifferentiated heavy lifting from your typical products. So imagine shifting the operational burden of maintaining a server from us to AWS and being able to leverage the existing operational teams that AWS has to help make sure that those services are staying up and to investigate if there are problems that users are servicing. Security-wise, you have components like identity and access management. They can give you the ability to lock down things like GraphQL APIs really simply and understandably with just a few simple JSON documents. And again, it's all pretty scalable. So AWS Amplify fits in here pretty smoothly in the development cycle. So you can use these open source libraries with things like your native applications. So you might have something running on Android, you might have something running on iOS, but you can also use it with your popular web frameworks like React or Vue. Beyond that, there are standard UI components that Amplify provides to you. You can incorporate in your applications, and there are escape hatches to what's actually going on under the hood. Testing, there's a really cool service if you're building these applications for iOS, Android, or web called Device Farm that essentially lets you actually test your applications on real devices, on real browsers, and see how they actually perform across a variety of different hardware. And for anyone who's worked in that app development space, you know how how frustrating it can be when you're trying to test on a variety of hardware and someone says, well, on my Samsung S8 actually doesn't work, and then you have to dig into the hardware level components. So Amplify helps you kind of solve some of those problems. Beyond that, you can deploy and host using Amplify, and it's simple CLI command or integration with an existing Git repository. And you can actually start tracking engagement and measurement using Amplify as well. So you can get things like, engagement and clickstream data for your websites, again, with simple CLI command to say, hey, Amplify, add an analytics to my application. So that's the Amplify overview. Sorry to start out with that, but it's kind of necessary to understand the rest of the talk. Not super relevant to the user group, but it is going to be relevant to the demo, and it is relevant to how you actually can develop these GraphQL applications on AWS. And you can see that it touches a lot of different components here, but the one we'll be focusing on today is this API component you see at the top row. Top row. So by adding APIs to your application, you can actually specify GraphQL APIs, and you can do things really interesting things around schema generation and automatic resolution between different components and different models that you have in your GraphQL schema. And I know I'm in the GraphQL user group. Didn't want to assume knowledge of the individual components here, but APIs are essentially the way that you interface the backend components of your system. And there are two predominant methodologies. You have REST APIs and you have GraphQL APIs. And in AWS, these are represented by API Gateway and AppSync, respectively. So these can interface with downstream, components like AWS Lambda to insert business logic, and can all access data sources within AWS or outside of AWS, as we'll see in some of the reference architectures. And essentially, if you've worked with REST APIs, you know how much of a mess it can become when you start calling 60 different endpoints to figure out, what a customer ordered on June 26th last year. That you can kind of spiral out of control when all you really want is, to call an API to get some information about a user. Then that user might be separated out between a ton of different data sources. So traditional advantage of a GraphQL API is the GraphQL API handles the collection of that data and synthesis of it to only return what you need. And here I just covered this. I'm not gonna beat you over the head with it. I've seen who's in the chat room, and I know it's not gonna seem super relevant. So here you can kind of see how Amplify ties in with GraphQL components. So if you look at the code, it seems really simple. It's importing a library from Amplify. You can import a actual query. So in this case, we're going to import the list to-dos query. And then from there, you can actually use the API imported from Amplify to call a GraphQL operation. In this case, listing the to-dos. Pretty straightforward. Should be really straightforward. And this is a lot easier than building out some of the mutation queries. And actually, Amplify can abstract that entire mutation and query component away from the GraphQL API architect. They just have to specify the schema, and all of these libraries can help them just make the queries, which is an interesting diversion away from the norm. And where AppSync comes in here is it's a managed GraphQL service that is serverless. And for those who aren't aware of what serverless is, it's basically an operational construct that says, as a customer, I don't want to have to worry about maintaining the infrastructure that runs the GraphQL queries and serves requests to users. I just want to know that I can call it, and I want to only pay for the consumption that I'm using for that service. So you're paying for the business value rather than the existence of a service somewhere. This is essentially the serverless value proposition. If you have a GraphQL API that's being called 5 times a day, might not make sense to run a server for the entire time when you can get consumption-based billing with a serverless product. Likewise, when you start scaling up, if you have server-based infrastructure, you might see a huge load when suddenly you run a promotion and go from 2 users accessing your website to 15,000 people because it got to the front page of like Hacker News. Serverless comes in here by saying, I want AWS to manage scaling my infrastructure out when I get this load, and I just want to know that I can call the APIs. Likewise, AppSync handles the connection to the actual data stores in your account. For those who are familiar with AWS services, this could be something like, an Aurora cluster, or it could be an Elasticsearch instance, or even a DynamoDB database. And we'll cover what these components are in a second. How do you do lookups? Sorry, I see a question in the chat. How do you do lookups between objects in Amplify and GraphQL? So for example, we want to display to-dos with the signing name of the avatar. Perfect. We're going to cover this in a second, and you'll see this as part of the demo. Essentially, you can create these queries that specify the variables you want to retrieve, and you can also configure the sources that maintain these data stores. So you might have a DynamoDB table that lists your to-dos, and those could have fields like names and their avatars, or even a link to their avatars, and you can implement some stateful behavior to retrieve the data at that link. Okay. And one of the more interesting things that AppSync provides is actually a scalable real-time subscription infrastructure. So let's continue with a to-do example. If you have a list of to-dos and you want to be notified whenever a new one comes in, you can create a WebSocket connection to AppSync. And then users who are listening to that WebSocket connection will have updates published to that WebSocket. And this is scalable. I've seen load tests done with tens of thousands of concurrent users on AppSync. And you can get these publishes pushed out really efficiently. And using some of the newer features, you get things like a GraphQL facade for basically any source within your AWS account, or also outside of your AWS account. So by shifting some of the business logic to a few other components we'll cover later, you can get some really interesting queries. And you can also implement things like conditional inserts. So let's say you want to only make this call if there's not an existing item that has the same item ID. That can be handled by AppSync. And likewise, you can get some really interesting authentication features out of the box. And these can be integrated with things like visibility for these subscriptions. So if you want to have a user who can only see the to-dos that they've submitted, you can actually do this by using AWS authentication services. And that's directly tied into your GraphQL schema. So we're going to talk about a few services that are critical to actually understanding how AppSync fits into production environments. We're going to cover these 3 services really quickly, but they're important to understanding the reference architectures I'm going to show you. So the first is Lambda. We just talked about these serverless services, and AWS Lambda is essentially a service that is a compute service, so you can put in arbitrary code. And the real goal is I want to be able to run this code whenever someone triggers a Lambda invocation. So some people might have a production application sitting in Lambda, or you might have some business logic that, in our case, modifies the results of a GraphQL query, or modifies the request that's being sent to downstream services after a GraphQL API has been invoked. Lambda sits all the way on that operational efficiency side of you just want to have code. You don't want to know where it's sitting. You don't want to know how it's scaling. You just want to be able to run that code. The other services here, we're not going to cover too in depth, but there are other AWS compute services. And you can see the on-premises component all the way over there on the bottom left of, you're managing it, you're paying for it, you're running it all the time. And you're figuring out how it's being utilized and how you're going to scale it up. And Amazon DynamoDB is also continuing this serverless trend. DynamoDB is essentially a serverless NoSQL database that's able to handle millions of requests per second and petabyte scale data. And it's also fitting the same consumption-based billing model. So one other thing to note about this is it's actually a very generous free tier. So if you're experimenting with how you can actually fit this in your applications, It's not going to, cost you if you're staying within the limits of that free tier, which is, a good way to play around and get some hands-on experience. And a few other things that it provides out of the box for you are global replication. So if you want to start shifting your data and having an active multi-region architecture, DynamoDB is a great service for that. And likewise, you get some interesting behavior out of streams. So you can actually get a stream of the change data capture into DynamoDB essentially, and then trigger other services within AWS for that data, or pull that stream to trigger other downstream actions based on a record being written into the database. And again, it's enterprise ready. We get things like transactional behavior, conditional behavior, global secondary indexes that can have a different ability to sort and query data, backing this data up, working with workbenches. It's all very, very standard. And the last piece that I think is very interesting for a GraphQL service is actually Amazon Elasticsearch service, which can be used as a downstream data source and integrates very smoothly with AppSync. So for an example of why this might be useful, imagine you have an API that's handling like forum data. You have users who are posting requests to a forum, and they want to have posts, they want to have likes or upvotes maybe, they want to have reactions, and but they also want to be able to search this data. So with Amplify and AppSync, all you have to do is add an @searchable annotation into your GraphQL schema, and suddenly the data is replicated not only to a database, but also to an Amazon Elasticsearch service cluster. And you can search through that cluster to get full document text search. Even if the record just has a username, you can search for the username, you can search for text inside a post, and you can get a really easy managed search environment out of it. The one thing that I'll note here, the service says fully managed. It's a managed service, but it's not a serverless service. This is a departure from the other few. And one thing to keep in mind when you are running production GraphQL environments is you will have to manage scaling the server out if you see that you're increasing load. So if you want to say, if you're having a production event and you see that you're nearing storage capacity, you might have to bump that storage up. But on the back end, AWS is the one who's managing provisioning that storage, adding it to your instance, managing things like rolling updates for Elasticsearch. And it's all very cost effective. So we have customers who are, utilizing this at scale and getting some really good benefits, especially from things like using Kibana as well. So the open distro for Amazon Elasticsearch provides some really interesting tools that you can extend your APIs with. For instance, things like unsupervised machine learning for anomaly detection on records coming into your backend. So if you have a GraphQL API that you're posting telemetry data to, suddenly this is very interesting for alerting. If you are sending data to Elasticsearch and also have anomaly detection running on the data, you can do alerting for operations teams to say, hey, maybe you should investigate, the instances that are running in our Sydney region. Very, very interesting application of the service. And like the other services we've talked about today, it's secure. It has a lot of compliance certifications. So you should feel really comfortable in using it for sensitive data and for production workloads. There's a lot of other stuff that AppSync integrates with, but we have 30 minutes here, and I want to get to talk about the GraphQL components and the actual architectures. So we have some customers who have some really nice things to say about how we're actually delivering results using Amplify and AppSync. So here, Hypertrack is a managed service that's actually doing live location tracking. So they have developers who are working, across industries, and they have location-aware appliances that they're counting on to power some real-time experiences. And they stream hundreds of millions of live location events between apps in real time. And AppSync is the backend that they use to actually do this. So it's leveraging the pub/sub components that we talked about a little bit ago, and it's leveraging Amplify to help speed the time to market. So the fun stuff. Here's a reference architecture for what this would actually look like in a mobile application. So you can see on the left-hand side, what we have is a mobile and web application that's using Amplify libraries. So you can see that those two components there. And likewise, we have the Amplify CLI that's handling provisioning our infrastructure and actually deploying the infrastructure that we specify. The key component that the application is interacting with is our GraphQL API sitting in AppSync. And you can see that AppSync actually interfaces with a few different resolvers here. So we have Amazon Elasticsearch, which we covered, DynamoDB, which we covered, Aurora Serverless, which isn't something that we talked about, but you can think of it as a relational database that can scale up or down like the other services that we talked about. HTTPS endpoints, which is very important for a few slides down the line. And keep in mind that you can call arbitrary HTTPS endpoints with AppSync. And AWS Lambda, which is our serverless function as code, or serverless function execution service. These HTTPS services, HTTPS resolvers and AWS Lambda resolvers can access the public internet, which is really interesting when you start considering applications for on-premises services. So one mistake that customers that I talk to can fall into sometimes is thinking that AppSync is only for the data sources in our account, or in our AWS account. When in reality, AppSync can interface across multiple different endpoints and communicate with multiple different backends, especially when you start baking in logic to your AWS Lambda functions. You can connect to your on-premises environments via services like VPN services or Amazon Direct Connect, which is an actual dedicated line for your on-premises network connections. So you can see that we have a few different options for whatever our mobile app really needs to do. So if our mobile app is something where we're serving e-commerce orders, maybe we want to push those orders into DynamoDB for storing metadata, storing the most recent transactions. We have transactional behaviors there. We have Elasticsearch service to query, well, hey, which orders did John order on December 16th of 2015? You can get that level of granularity in the search, or you can also get a very loose search on things like who has ordered pet food. Likewise, you can have AWS Lambda endpoints that might interface with your legacy reporting systems in an on-premises environment, or maybe you have microservices that still sit on data center hardware that you have provision for a yearly contract. That's a very simple use case, but one of the more advanced use cases that we have with AppSync is actually baking in stateful logic to these resolvers. So the way that works, you can also, just do this very simply via AppSync, but you can actually start baking in logic to help you only query the downstream resources that actually need to be queried as part of a request. So let's say we have a request to an e-commerce service where, we want to know what John ordered, and we want to know what John historically ordered from our on-premises CRM system that we've had, legacy order history in. We can query Elasticsearch to get all of the records that are tagged with John's specific user ID or John's, full name, so some unique identifier about John. We can do search there. And then we can actually process those records, do things like record deduplication, or if the record has the information sitting in the actual Elasticsearch record, and we don't need to query the legacy system, we can remove those records as part of the templating process. We can then do a pipeline resolver to go to the next step and retrieve only the objects that we actually want. So we will retrieve the records where we're missing data that we know is on the legacy CRM. And we can query Lambda, and here I have my S3 example. So we'll continue with the CRM because that's what I've been explaining. Just imagine that arrow is going to the actual compute cluster over there. So from there, we can get back those set of records, and we can return the enriched records that have the data that's sitting only on the legacy CRM side. So this is an interesting way to avoid, querying the legacy CRM for every record that's in the initial set. Like a naive implementation here might be querying the backend, getting the records back, and then sending the records, or querying the legacy CRM for all of the records, and then, kind of missing that data, or having to handle logic on the client side that really should be handled with a single API call. So this allows you to pack a lot of power into single API calls, and we'll see a few more examples of how you can actually use this in practical applications later. Likewise, we talked about HTTPS endpoints, and they're really powerful for endpoints both in your AWS account and on your on-premises systems. So here we can imagine a microservice architecture where we have a user service that's sitting in AWS behind an API gateway instance. This API gateway instance invokes a Lambda function to get information about users. Likewise, we can have something that has order metadata behind another AppSync API that we can actually invoke through this resolver. So you can chain these APIs together by using HTTPS endpoints. Then you might have an on-premises system that has the actual, ledger of, order transactions, and because the historical data is there, maybe you keep sending the data there. Who knows? It's a design decision that your company might have made. And here we have a single AppSync API that's able to interface and retrieve data from all of these services and give a full picture back to the user about, let's say we want to know John's total spend for the month. We can go through, query the user service to get information about John and John's unique identifier, have pipeline resolvers to get metadata about the orders that he's purchased. And we can also enrich that data with the actual ledger data that's the append-only log of John's order transaction history to get the final result and send all of the data back to the user transparently with a single API call. But that's a really optimistic example. We have a lot of systems there. And one thing I haven't mentioned is that AppSync resolvers traditionally use a markup language called, or a templating language called velocity templating language, uses VTL. And you have to specify VTL definitions of how to transform your requests and responses to give that data back to a user. And when we're talking about integrating with other teams' downstream microservices, that means we might be tightly coupled to the returns from those microservices. So for example, if the user service suddenly changes the way that their return is formatted, like if they remove the, John's unique identifier and rename it to, user UUID or something because they felt like ID wasn't specific enough. Suddenly your templating language that you've defined might not be working anymore. And likewise, when you start integrating with legacy systems, where the return type might not change very much, but you might have some very strong or some very large templates to actually handle the sometimes bloated responses from these services. It's not ideal. It doesn't look great. It's not super easy as far as the development experience goes. But the interesting thing is AppSync has recently released direct Lambda resolvers. So these direct Lambda resolvers actually allow you to bake business logic into that request and return process. So as part of the request, you can actually start, looking at how you can actually shape that return. So if your front end is expecting a specific, sorry, I thought I saw a chat message. If your front end is expecting a specific return shape, like if the object is supposed to match specific schema, then you can actually bake that into your Lambda and ensure that your front end is getting the return that it's expecting. And using standard ways to interact with like JSON objects and from code, you can bake in some really reliable behavior. So that was a lot of talking, but I mentioned that you can build APIs in minutes, so we should probably build APIs in minutes. Let me share my screen quickly. So let me drag this away. Can you see my screen here? You see the terminal? Let me bake up there.
Yeah, we see that.
Sorry, 1 second.
I want to make that text a little bit bigger.
The hotkey is not wanted to trigger. I think Zoom is taking priority. Yeah, I have to keep clicking. Sorry, guys. Okay, is that visible? Is that visible for everyone? Or still too small?
Yeah, it looks all right to me.
Okay, I'll give it a few more bumps up. View bigger, view bigger. Okay, so where we're at now, I've created a simple React app. I did it before the stream because it takes quite a while to finish that create React app cycle. So you can see we just have a standard layout here from the create React app running. So to init Amplify, it's pretty simple. First of all, to install it, you can just do npm install -g, AWS Amplify. Their install guide to the internet. I encourage you to check there. But I have it installed already. All I have to do is run an Amplify init. So it's asking me for a project name. We'll use the defaults going through. I want to use Visual Studio Code to edit. It's my preferred IDE. I'm going to use a JavaScript application here. I'm using React. It knows that because I'm in a folder with the React structure. My source directory is source, build, standard build command, standard start command. And now it's going to trigger an AWS CloudFormation script, which is basically an infrastructure as code component that's deploying actual resources into my AWS account. So I'm going to use my default profile. This has my AWS, information to basically authorize it to create the resources in my account. While it's doing this, does anyone have any questions? I don't have the chat window open, so feel free to give a shout. Cool. In that case, we're going to wait for this project to init.
Just one question. So is the Lambda resolvers public? So is that something that everyone can use right now?
Yeah. It was released a few months ago, I believe.
Awesome.
I think it was in August.
Okay, cool. Very cool. Yeah, I've done a POC with AppSync with the VTLs, and that was interesting. So very excited to see the Lambda one out now.
Yeah, no, the VTL is not my preferred language to interact with, either at the GraphQL or REST layer with the API gateway. Okay, so we've deployed infrastructure into our account, and now we want to add an API. So that's pretty simple. Just type amplify add API. And select GraphQL. We'll use the defaults again. I'll use an API key here. We could bake some authentication in, but we don't have that going right now. API key, just going to use default. It expires in 7 days, and I don't need any event settings. So I don't have a schema, so I want to make a new one. And let's use that simple to-do example. So this is actually going to create a basic GraphQL schema for me. Pop up in a second. Do I want to edit the schema? Yeah, I want to edit the schema. Okay, so it opens my IDE. And cool. So I'm going to open my notes in my other windows to make sure I don't mess this up too badly. But when I saw this, I was like, a to-do example is not that exciting. It's a single model. So maybe to expand this, we should actually do something. Oh, my lights just went out. Unfortunate. To expand this, we should do something like add a sprint type. Maybe we're creating a sprint board that actually has to-do items in it. So we'll create a type sprint. It's a model, and it'll have an ID. It has type ID. Name. Let's make the name a string. And it should have a concept of tasks. So we have tasks, and those are of type to-do. But it's not a single to-do. It's a set of them. So we have an array of to-dos here. And our to-dos are also not super interesting for a sprint board. We have a name, we have a description, but should also probably be associated with a sprint ID. And that's also going to be an ID. It should be, probably have an owner. Let's make that an optional field. Things like priority are going to be important as well. So priority, and starting to look a lot more reasonable as far as a schema goes.
Sorry to interrupt, Rob. Would you be able to just make the text on your text editor a little bit bigger
absolutely.
as well?
Absolutely.
Please, thank
Sorry
you.
about that. There. Is that a bit better?
Perfect. Thank you.
Okay. No stress. So, but right now we have this concept of tasks. We have a concept of a set of to-dos here. but we don't have is an actual component that's linking them together. So what we can do is actually create a connection here. And this connection is actually going to be able to link our different to-dos together. So, or to link our to-dos to our actual sprints. So our connection is going to have a key field. And that's going to be called by sprint. So this will be used by the to-do. So this is just the name we're going to use to reference this connection. And as far as fields go, we'll just use the actual ID of the sprint. So we're referencing this field here for that connection. So we have a key that we can now reference in our to-do that leverages the primary key of the sprint, which is its ID. So we can actually start using this key by giving the to-do a key annotation as well. So we have a key here. We can have, let me try and remember the name of this annotation. Oh yeah, it's just gonna be sprint. And we can have at reference a field, sprint ID, and the actual to-do. So we have by sprint referenced from here, and we have sprint ID, which is a field and the to-do. So that's pretty interesting. One thing we might also want to do, like I might want to be able to be notified whenever a new to-do is created. So as far as that goes, I'll edit this model annotation and give it a subscription. So subscriptions level level will be public. Cool. And oh, I don't need the actual brackets here. Okay, so I've modified this pretty reasonably. Let's save this and head back over to Amplify. And I actually want to test that API. So I'm just going to run an Amplify mock. So this is going to validate my schema. It's going to try and build it. If I messed up, this is going to be the moment of truth. Are there any questions so far while this generates the mock endpoint? Cool. So now I have a mock endpoint that's running. And I can load this. Sorry, let me find my browser. Just being hidden by everything, sorry. Zoom is not playing nicely with me. Okay, so now we have a GraphQL Explorer where we can start actually playing around with the schema we just created. And it's going to be actually using DynamoDB on the back end to make sure that we're actually doing things that are feasible. So if I want to add a new mutation, I can just go ahead and add a new mutation. Let's say I want to create a sprint. And my sprint name is going to be Sydney GraphQL. And I want to actually get my ID back. I want to know when it was created and want to have the name returned to me. Cool. So now I have a record persisted in my DynamoDB backend. And we have an ID here. So let's make sure that our to-dos can actually be referenced successfully. So I'm going to add a query variable. So sprint ID is that. And my mutation has the sprint ID, gets an ID. And I want to now actually create a to-do. So this to-do will have a name, first sprint item. We'll have a sprint ID of sprint ID, and has a priority. We'll leave out the optional fields for now. And then basically we want to get back, some of the information here to see.
Sorry to interrupt again, Rob. Would you be able to make the text bigger again, please?
Yeah, sorry. It's gonna keep happening, isn't it? Sorry. I'm not sure if it's one of my keys not working, but that hotkey is not my friend today. Cool. So is that visible for everyone?
Perfect.
Easy. So we have our mutation here. We created a new item in the to-dos, and now to make sure that they're actually linked together, if we do a simple list, so if we want to go through, add a new query, let's actually list our sprints, and let's get back all of our items. Just see where they're at. Sure, this should be fine. Classic. Sprint ID. So let me list my items. List to-dos. Oh, that would explain it. It's the wrong ID. Okay, so there we go. Okay, so now if we just go ahead, get our mutation back. Second sprint item. Cool. Query. I will list everything. Perfect. So now we see our items are being returned in the to-dos. We have the first sprint item and the second sprint item. I guess I did my query incorrectly the first time. Cool. So we can see that that connection is working as intended. And that's kind of cool. But overall, we haven't really shown how Amplify can actually speed up, the actual GraphQL, front-end logic component. So let's go to an actual React app I have sitting here. I changed it a bit. We have some sample data here that's being pulled from the API. And let me open up developer tools here. Let me make that bigger before. There. Okay. So how can we actually start using these APIs to get some interesting information? So we have that subscription field there. So let's maybe make a subscription for the to-dos. So, or even the actual sprints. I have a little sample here of just when any sprint's created, we'll just get that sprint ID. So we have a subscription ready there. And that's a pretty simple query where we just have a GraphQL operation that's being called. It's the subscription operation that's created automatically for you. So as part of that previous Amplify add or schema definition that we did, these operations were created for you. And for the subscription, when we get the next item, we'll take the data, we're just going to log the data, and then we'll set the window variable sprint ID, just playing around here. and be able to look at that. And to actually create that new sprint, we'll just do a quick GraphQL operation, create, and from there, we'll have our input, which is going to be just name, sprint, and that's all that that's going to take in. Yeah. Classic. Variable input has coerced the null value. What am I missing? Oh, sorry. One thing that was different between the two APIs here is that this one actually has a description field as well. So for description, we will have I'm creating it to do not a sprint. That is so it's the worst when you go through this like an hour before and you're like, I'm ready to go. And run through the demo. Everything runs fine. There we go. Okay. So now we've logged the data here. So that's the result of running that subscription from our subscriber. So we can see we ran on create sprint. We have our ID here. So we know it's actually at the back end. And we have our tasks, which you can see is empty. And to actually, do something like create a to-do, we can look at saying what were our required fields. We say API GraphQL operation, do input, and for our input, our required fields were the sprint ID. So sprint ID is sprint ID, because we set that as part of the previous subscription. Then we have the name. So then we have the priority. So let's say it's a really important item for us. We want to make it priority 4. And those are all of the required fields for this call. Unexpected identifier. Oh. Perfect. Should have probably resolved that or then that. Like if there's an item. So we can see the return here. We've created a to-do, has an ID, it's associated with our sprint, and we can actually start seeing things. And so one of the interesting things here is this list here is not using the subscription API. It's just calling list, and when you interact with components, you are, getting it updated. It's not really doing any polling. But you can see how subscriptions would be very useful for something like a sprint board where multiple people might be using the same components at the same time. So in reality, you wouldn't want this page to be static, and you wouldn't want to have to sit here and refresh to see like, hey, we actually added a few new sprint items here. And you can see that this isn't actually going to trigger a static website. We have a second sprint item, and you can see that all of our stuff is persisted, but this should show you the value of actually integrating these real-time pub sub components into your front-end applications and your web pages. And let's say I want to push this all to AWS. Let me find my VS Code window. But maybe I actually want to be able to search those to-dos. I'll add searchable and save my schema. go back over to my terminal. You can see that the mock doesn't work with the Elasticsearch component. That's fine. At this point, we're pretty confident that our infrastructure is working as it should. And we can push this all into AWS and have it run in our, development environment here. Let's just do that as the dev environment. You can start doing interesting things around CI/CD. You can start doing interesting things around having multiple, dev test prod kind of environments. All of that's supported with Amplify. You can see it's asking me, sure you want to actually push this up? Say yes. And now it's going to go through the process of deploying the CloudFormation to your account. Here's just generating that SDK we're just using. And now it's going to deploy. Cool. That was it. Does anyone have any questions about any of the stuff that you saw?
What is the backend database used in this example?
Oh, cool. Good question. 1 second. Let me show you. So, 1 second. I need to log into my account quickly. And to look at all the things that are deployed. Sorry, I was just slowly checking through our SSO here. To show you everything that was deployed as part of this, we can go into CloudFormation. You can see here's the most recent deployment. Which one is this? The connection stack, the searchable stack, the sprint, and to do. So let's take a look at the sprints. You can see we have resources here, and we have AppSync revolvers, and we have AppSync data sources. But behind the scenes, we have this DynamoDB table. So if we go into this DynamoDB table, you can actually see we have items here that correspond with the items we just created. So the answer to your question, that's pretty long-winded. DynamoDB is the backend data source.
Thank you. Did we pick this during the project initialization? Or
so it's the default. However, like you see, you change the backing data sources that you're using by using those, at annotations in the service. So you can also see we have a second component here sitting in Elasticsearch. So you can see Amplify has actually been creating Elasticsearch components, and we can go through. We can go ahead and actually look at Kibana. I have to configure the Cognito for the Kibana. Haven't specified that here, but essentially, if we start running queries against this endpoint using our IAM authorization from our account, we can actually start querying those records as well. And all we did to get that was add the extra searchable annotation. Likewise, you can interact with things like, RDS or Aurora, rather. But if you want to change that as well, so I'm going to keep running until someone else asks another question, because I think they're all pretty interesting to explore. It's pretty simple to change. So if we take a look, my bad naming is coming to bite me here. Naming things the exact same thing is not recommended. You can actually take a look at the schema that was generated. So you can look at what's going on here. And likewise, you can look at the actual data sources that are being used for the components here. So we have 2 DynamoDB data sources, but we could create a new one. We might say new data source. And maybe the data source type is, that a Lambda function that's querying our on-prem resources. We create a new data source, and it's sitting there ready to use.
And how would you connect to this in the schema?
So from the schema, where is the, sorry, one second. It's going to be part of the queries, right? No, this is the GraphQL. I'm so used to doing it with Amplify at this point, I've kind of blanked. Happy to get back to you with that. If you'd like to provide an email address or something, I can send you over some more information.
Yeah, that'd be great. Thanks.
Yeah, no stress. Any other questions there?
What does the update looks like? The update arguments.
The update. So you can just do that as part of the mutation. So if I go through and where's my React app here? So let's say I'm creating a to-do. I haven't exported it here. One second. Let me change this React app really quickly. So the reason I'm setting these is just so I can interact with it from that dev console to kind of show you what's going on. So let me reload this page. So first of all, let's go ahead and create a new item, say 4th sprint item. What was our, here,
Just
I'll do the same process again. Does it make sense?
Yeah, I just wanted to see the inputs, basically, input arguments.
Oh yeah, so essentially the way you change it would be update to do, and then as part of that, in this case, because we don't have another primary key for the item, we'd have to specify the actual ID as part of the update. But we can change the actual schema to have a different primary key potentially, or have a different primary key and sort key combination. So the reason you would do that would be something like, if I have like a timestamp here, and I have a field of AWS timestamp, I require it. If I wanted to create a new index, I could do key name, sorted to-dos, fields would be the primary key, which in this case would be, we could do something like the name of the sprint item, and then the sort key of timestamp. Then from there, we could label that as time sorted. Sorry, I need to query field. I believe that is correct. It's going to yell at me if it's not. So let's see. Oh, it won't yell at me if it's not, because it's still creating this. Essentially, typically, you'd see the GraphQL API, or you'd see Amplify in the background if you tried to run a mock for this and it's incorrect. Builds a schema, would tell you what's wrong. But right now, I'm fairly confident this is right. You'd have a global secondary index with a primary key of the name of the sprint item, and then the time sorted by the timestamp. So you could query that by using this method from GraphQL. So essentially, it would create another method and the SDK for you to call. And likewise, you'd be able to do updates on that actual field. Does that make sense?
Is there any way to run this offline completely? Because it sounds like even the mocks run on a provisioned Dynamo.
Yeah, not that I'm aware of. Sorry, I realized I'm completely in the dark right now. So one second. Yeah, no, not that I'm aware of. Even some of the components that do run in an offline state, like if you're familiar with serverless application model, that's essentially a nearly entirely offline way of mocking out Lambda functions. Still use provision DynamoDB. And the reason for that is it's consumption-based. So for these kind of testing workflows, it's really not that impactful to run like 30 queries against DynamoDB. It's going to charge you maybe, a few cents potentially. And if you're in that free tier, it's not going to charge you anything. So one of the nicer things about the serverless constructs here is it makes it really simple to test against what your infrastructure would actually look like in prod. I'm going to turn on the lights really quickly. I can still hear you. So if someone wants to follow that up or ask another question, just give me a shout. See if there we go. Any other follow-ups to that or questions there?
AWS timestamp field, will it update if we update that record, or is just one time?
That would be a one-time thing. So this is essentially saying you have to provide a timestamp. So this exclamation mark means required, means we have to provide this timestamp field, and epoch seconds is essentially what that's specifying. AWS timestamp is just a little wrapper around epoch seconds. And what you're really looking for, if you're looking for when records are updated, is here. Man, I wish I hadn't refreshed that page. Essentially, there's a created at and updated at field that's returned as part of the record. So you'll be able to see the initial creation date and the last update of that record. If there are any other questions in the meantime, happy to answer. I can set up my subscription. I'm buckling this now. A subscriber should fire. Unless I've already created that sprint name. But yeah, essentially the answer to the question is just the created at fields and updated at fields. And they're also visible from Amplify mock. So if we go through, create a new window, CD, you can see them specified as part of the graphical interface. If there are no other questions, I can show that little component there and then drop off. Cool. So it's really going to open up. If you don't need me to show it, oh yeah, because I have miscapitalized letter. But I think you get the picture. Cool. I will stop the share now. If there are any questions, please just let me know in the chat. I'll linger around for a bit. And happy to follow this up.